Hi, everyone. My name is Cami or Camelia. I am with the School of Engineering here at USC. Thank you so much for joining us today. This morning, we're going to be talking about our Master of Science in Applied Physics. And we're very pleased to have Dr. Michelle Povinelli here, who is professor in the Electrical and Computer Engineering Department. I oversee the admission and the outreach here for the School of Engineering, so I'm really happy to see the interest in our Applied Physics program. What I'm going to do is just take about 2 minutes and just kind of give a quick overview of the university and the School of Engineering, and then I'll turn it over to Dr. Povinelli. Okay, so for those of you who don't know just a little bit about USC, we're obviously located in Los Angeles. We're one of the world's leading private research universities with 22 academic schools and divisions. And as you can see, especially with this applied physics program, the School of Engineering is really an advocate of interdisciplinary education and really seeing how engineering cuts across many other disciplines. And of course, we do welcome applicants from areas outside of engineering. We have a very diverse student population here with students from over 110 countries. And in engineering, we have applicants generally every year from over 70 countries. There's 450,000 alumni worldwide from USC, and our engineering graduate programs are ranked in the top 15 by US News and World Report. So that being said, I'm going to go ahead and turn it over to Dr. Povinelli. I'm going to stop sharing right now, and then I'll allow her to share. Okay, Professor Povinelli, if you'd like to go ahead. Sorry, Professor, you're muted.
Yes. Hi, sorry about that. Unmuted now. Hello, I am Professor Michelle Povinelli. I'm a professor in electrical and computer engineering here at USC, and I also have a joint appointment in physics and astronomy. And here to talk to you today about the Applied Physics Masters, which is a new master's program that we are starting here in the school. So I see we have several students joining us. I would love to see where you are coming from in your undergrad major. So please go ahead. If you're online, you can go ahead and type that in the chat so I can see where you are now and also what you're studying. While you're doing that, I will put up our screen to tell you about the program. Do they have access to the chat? I wonder if they're able to type. Yeah. Okay.
Yes, you should.
Right. So yes, please feel free at any time. Love to see where you're from, what your undergrad school and major is. So let me tell you a bit about the MS Applied Physics. This is a new program at the school. And the real motivation behind this program is we would like to provide a pathway for students who might come from a physics undergrad background or an engineering background, but with strong interest in physics, to explore the areas within engineering that really use physics and use knowledge of physical systems in the context of practical problems. So I personally, I had an undergrad degree in physics and actually a PhD in physics, but my area within engineering is optics and photonics. And that's one of the areas where having a really good knowledge of mechanics, of quantum mechanics, of E&M is useful because the things we do are based on those physical models. Okay, so this pretty picture you see here, this is a nice remote sensing imaging of what crops look like from the air. And you see these color-coded patterns. What this illustrates is one example where we can use electromagnetics and electromagnetic scattering to understand something about agriculture, crop health, and to do so using sophisticated technological methods. So for example, one of our faculty members here, Professor Mogadam, works in this remote sensing area. And we have other groups here, including my group and Han Wang's group, where we are developing sensors for that purpose. I see a hand up, so let me check the Q&A while we're talking. Okay. So more generally, This program is for students who have interest in sort of this hybrid area between physics and engineering and want to know what engineering topics could benefit from their knowledge and interests. So some of these areas would include things like radio frequency electromagnetics, the study of antennas, remote sensing, things like photonics, so the area of optics and photonics, as I mentioned. And in some cases, certain areas of other engineering disciplines like aeronautics, mechanical engineering, and biomedical, where there's a strong physics component. So as a student in this program, the idea would be that you can transition into the master's program, get some theoretical basis and knowledge to augment your undergrad degree, and then explore opportunities for you, whether that's to do a PhD afterwards in one of our engineering departments in Viterbi, electrical engineering or mechanical engineering, or to go directly to industry. So we have two main pathways. One would be that you do the master's in order to transition to PhD, and the other would be to do the master's and then transition to industry. All right. Okay, so let's take a little bit of a look at how our program is structured. I'm showing you the web page so that later, if you want a reference for what I'm saying, you can go back and look directly at our MS Applied Physics webpage, which you'll be able to find by typing USC MS Applied Physics. If for some reason that doesn't get you to the right place, please feel free to go to the Electrical Engineering Department at USC and look through our master's programs. This program is administered by the ECE department. Okay, so the way that the program is constructed, we have a few core classes which are meant to give you knowledge that is very general, that can be applied in a number of different areas, but is also very deep and technical at the same time. So let me talk about that. These are our two core classes. The idea of these two classes is to give you methods that help you understand, model, and predict behavior of different physical systems. So the first is computational methods in applied physics. And so that's EE 604. And you can read the description here. I won't read the whole description out loud, but the idea of 604 is it's giving you basic tools for how you solve differential equations. We know that many physical systems, whether that's in aerospace, in applied physics, in photonics, many physical systems are modeled by differential equations. And thanks to the fact that we're living in 2022, we have all sorts of numerical methods available to solve those differential equations. And so part of this class, 604, this is really about methods for solving linear and nonlinear ODEs, PDEs, and stochastic differential equations. So there's a lot of modeling, and that's all done in the context of different applications, different physical phenomena that involve either photonic modes, radar cross sections, metasurfaces, nonlinear physics, etc. So you'll be learning methods and seeing how they apply to particular physical problems. And then you can take those methods and apply them in whatever area that you go on to work on. The other course is machine learning and computational methods. Everyone wants to know machine learning these days. We're seeing a rise in the popularity of machine learning and its applications. So this is to introduce you to machine learning and computational physics. The idea of machine learning algorithms, of course, is that we can use existing data sets to look for patterns and train the computer to recognize those patterns. And you will learn about how neural networks work, how to code those, and how to analyze data using neural nets. All right. Thanks for typing in the chat. Got that. Okay. Good to hear from you. Okay, so then once you do the two core classes, or in addition to the two core classes, you will then choose an area of specialization. So the core is your foundation. And then after that, you take a 4-course concentration. You can pick either electromagnetic wave propagation and scattering, optics and photonics, or mechanics of fluid and solid media. So let me tell you a little bit about those areas. Electromagnetic wave propagation. Of course, electromagnetic wave propagation underlies a lot of the things we see around us in the everyday world. Our cell phones are communicating through the air with electromagnetic waves. Most notably, all the signals that go through the internet. So the way you're getting this video right now is electromagnetic waves coming through optical fibers. And so in this specialization area, you take a graduate electromagnetism class or graduate electromagnetic theory. And then after doing that, you go on to choose some elective courses in this area. So it could be computational electromagnetics for engineers, could be antennas, could be advanced electromagnetic theory, could be understanding wave interactions with random and inhomogeneous media. So depending what you're interested in and what your career interests are, we can help you choose from this list. Second area that you can choose to concentrate in is photonics and optics. And so in the photonics and optics area, we are also looking at electromagnetics, but a little different flavor of electromagnetics, where you're looking mostly at visible light, near infrared light, where optical telecom happens, and uses of those wavelength ranges for practical applications. So there's a foundational class which introduces you to the area of photonics, optical materials, instruments, and devices. And then you can choose other classes in this concentration that would include quantum mechanics, quantum electronics, which is laser theory, nonlinear optics, and optical information processing. Third area you could choose is mechanics of fluid and solid media. So if you really liked the mechanics part of physics and you want to go further into mechanics, this program is joint with the mechanical engineering department, and you can see how some of that basic material that you learn in physics can be applied now to fluids and solids. And so in this case, the classes that you might take, you would understand continuum mechanics, which is the mechanics of solid materials. I was going to lift up my coffee cup, but my coffee cup is not a solid material, but in fact the lid, if we push on the lid and want to understand how the lid responds to a push, and we need to understand things about the compliance of materials and the mechanics of materials. So continuum mechanics, applied elasticity fall in that area. And then there are other classes you could take that would get into either combustion, heat and mass diffusion, or understanding vibration. So for students who want to get in a more mechanical engineering direction, they might choose this concentration to transition from an undergrad physics major into mechanical engineering. In addition to your concentration, you do also take a breadth class. You would also choose one class outside your concentration. Okay, so feel free to type any questions you have now that everyone has the chat. Please go ahead and type any questions you have in the chat. I'll be answering those as I see them come up, and I'll make a few comments on what I see so far. So we have someone here with an undergrad in physics and someone with an undergrad in data science. So that's great. We consider a range of undergrad majors for this program. The basic requirements in order to be admitted to the program is that you would be able to take the types of classes listed here. So in other words, you could have various undergrad degrees in either physics or engineering, as long as you have done some preparatory work that would allow you to take the classes we just talked about, which involve a lot of math and math modeling, as well as data modeling. So an undergrad major in data science, an undergrad major in physics, these can all work, provided that you have been positioned to sort of dive in and learn things about numerical methods and differential equations. So practically speaking, it would be great if you have an undergrad class either in differential equations as a math methods class, or you have exposure to differential equations through your physics classes. So I know many physics undergrad majors may not take differential equations, but you see different differential equations as they arise in the context of the physics classes. So you're doing mechanics, you see some set of differential equations. You do electromagnetics, you see a different set. Great, aerospace. Okay, so engineering degrees, undergrad degrees are also possible. If your undergrad degree is in a specific engineering discipline already, you have two options when you look at our programs. You could always look at our master's programs in that same discipline that you did your undergrad, or you could consider this one as a kind of an interdisciplinary option. For example, let's say that you are in aerospace or a particular undergrad engineering discipline, and you are wondering about moving into EE or mechanical engineering, but you're not sure how to get there. This is also another possible pathway would be to go to do the applied physics master's, and then within applied physics, sort of reorient yourself as to which engineering discipline might serve you for a PhD. All right. In terms of how long, I know you're probably wondering, how long does it take? How long do the master's programs take? What are the requirements? So as mentioned here in the program structure, this is typically 7 courses. So how long does 7 courses take you? Probably 3 semesters. It's possible that if you were possible, but unlikely to do it in 2. That would be very hard, I think. I know that as an undergrad, you take many classes at the same time. So our undergrads are taking 4 classes at the same time. When it comes to graduate classes, things change a bit. The graduate classes typically take more work. You probably would not want to take more than 3 at a time. So you would be looking at 2 to 3 semesters, but maybe more likely 3. And so that means that if you start in the fall, you're looking at fall, spring, and then maybe the following fall. While you are here as a student, we have a really wide range of career services available through the school. So as one of the preeminent engineering schools in our region and in the country, we have a really good career services team, and they will work with you to help identify opportunities that you might be eligible for. For the domestic students, that's to do summer internships. For international students, you also qualify through the for some of those internships and opportunities through CPT and then OPT. So there's a technical name for the fact that as a student, you have opportunities to do internships at the same time as you are in a degree program, usually during the summer. So usually when you're not taking classes. And then after graduating, you have opportunities to work in industry for some period of time that come from having the degree in the US. And so during this time that you are a student, you can make use of all of those services. We have a sort of all the things you would expect. We have career fairs where representatives from companies come and look for students. We have informational sessions all run by our career services team. We have meet and greets, different events, which are all designed around supporting students in this transition for those students who want to go to industry. So if you're thinking about industry and you'd like to get into industry, you can take advantage of all those services. If your goal is to get a PhD first, then in that case, as a member of, as a participant in the program and as a student in the department, then we have a student services team that can help you look at which courses to choose, scheduling, and then which of those courses might apply to a PhD program. So if your goal is to eventually do a PhD and you come in as a master's student, then we can advise you on which classes would also count towards a PhD if you were wanting to transition to that program eventually. Right, so I will pause there. Let me see if anyone has questions. Please go ahead. If you have any questions, you can put them in the chat. And while we're doing that, I can also ask our admission team. So is there anything that students, any questions that you have that I should cover that you hear from students in these sessions and that hasn't been hit on yet?
I could ask one question that students might ask as they're in the master's program. Is there opportunities to do research in any kind of way?
Yeah, so While you're here as a master's student, we do have many master's students who volunteer in research groups. And within ECE, we have quite a large number of faculty overall. So we have something like 60, 70 faculty in ECE. And then we have our mechanical engineering faculty, so that's maybe another 20. And so there's a wide range of research going on. If you, as a master's student, find a group that sounds interesting to you, many groups take master's student volunteers. And so master's students can get involved in research and sort of participate in that way. And that's done sort of case by case, depending what your interests are, then the type of lab that you might be interested in working in would vary quite a bit. But we have really wide range of things going on. And the research that is going on directly relates to these topics that you're seeing in the MS Applied Physics. So for example, if you're interested in EM wave propagation and scattering, we have a couple of groups. We have one, and maybe even three. Okay, so we have one group that works a lot on remote sensing, understanding climate and agriculture and other sort of features of the Earth's surface, water distribution, understanding like environmental ecology using remote sensing or electromagnetic scattering methods. We have another group that does electromagnetic wave scattering for understanding the brain and for understanding neural implants. The picture here is some sort of device for treatment of brain cancer. So we have at least one group that's looking at electrical signals and how they propagate and how waves propagate within the brain in order to develop therapeutics. So a different exciting and very different application area. And I can go through the list. Any of these things that we pick, we have groups working in. So in the optics and photonics area, we have a very strong program here with about it's at least 6 faculty working in this area. Wave scattering, lasers. We have nonlinear optics, we have infrared metamaterials. we have a large program in optics and photonics that you might get involved in. And then in the mechanics of fluid and solid media area, the mechanical engineering department has a range of activities going on there as well. So I have one question, which is the admission requirement, and whether there is a GPA requirement. Okay, so there is no published strict cutoff for GPA. The admissions done case by case. We look to see, do you have the type of undergrad background that would let you take these classes? So are you coming from either a physics or an engineering background with enough prereqs that you could jump into this numerical methods for differential equations and machine learning classes? So any major that satisfies that preparation will be considered. And then there is no strict numerical cutoff. I would say as a rule, many graduate programs tend to have an unofficial cutoff around 3. So I think it would be, I'm not saying everyone above a 3.0 gets in, but I am saying below a 3.0, you'd have to have a very compelling story in some other way. So if your undergrad GPA is below 3.0, you would need some other factors on your transcript saying that you were a really promising student in spite of this GPA. But I think as a rough cutoff, we could say 3. And then after that, we look sort of case by case. Better than 3 is better. Other questions? Okay, TOEFL score cutoff. I don't know the answer to that. Do you know the answer?
Sure. The TOEFL, so if you're an international student, which it seems like some of you are, you do need to take the TOEFL or the IELTS. And the TOEFL, the recommended score is 90 with 20 on each section. And on the IELTS is 6.5 with 6 on each section. And here at USC, it's a little different. So we we do admit students who have slightly below those scores. So it's not, those scores I just gave you are not requirements for admission, but you do need to strive to get those scores, because if you do get admitted and you have just a little under those scores, then if you come to USC, you'll be required to take an English language exam. And then if you don't pass it, they'll make you take an English language course. So it's in your best interest to try to strive for those scores.
Yeah, so to say a word about that, for students who do come in with a low score, what happens then is we have a language institute, and students whose scores are initially deficient, then they go to courses for speaking, listening, pronunciation, etc. And you take those courses until you sort of come up to proficiency or professional proficiency to, live, work in the US professional environment. So the higher you can get them ahead of time, the more of those requirements you can waive. A lot of students waive those completely. But if your score does come in low, then you would be taking English to sort of boost your proficiency at the same time.
And if I could interject here with Francisco's question. So if your TOEFL score is 88, then what you can do is you can still apply with that score. But then if you do get admitted, my suggestion to you is to try to retake that TOEFL so you can get over the 90.
Okay, and then test scores. We have another question just about test scores in general. Do we have any other test score requirements other than the TOEFL?
No, so the GRE exam is not required for this upcoming application cycle. And in future years, that's still to be determined, but at least for the applications for fall of 2023, they're not required for the GRE.
All right. If there's anything else you'd like to know, you can go ahead and type. Let me say in the last few minutes here, while I see if there is a other question. Okay, I'll say a word about Los Angeles. So I see that people who are attending today are attending from all over the world. We are located in Los Angeles. I know everyone is somewhat familiar with LA from the movies. It is true that it is very warm and sunny. So we are a very warm and sunny city, and we are a very large city. And so I think you'll find there's a lot here, no matter what your interests are or your background. So, within the larger LA area, you can find like any kind of food from around the world that you could ever want to try. You can find multiple restaurants giving that type of food. If you like hiking, you can find mountains to hike in. If you like the ocean, you can, of course, go to the ocean. It's a very large city. We are not all movie stars. You think LA movie stars, it's not like that. When you get here, we're not all movie stars. If you do want to go watch for movie stars, there is a neighborhood you can do that in. But basically, LA is a very large city. And then California as a region has a lot of employment opportunities post-graduation. So you don't have to stay in California, certainly, but a lot of students do. A lot of students like to remain either in the Southern California area or go up to Northern California after graduation. And so we do see a lot of hiring to companies throughout the region. San Diego is about 2.5 hours away. And between here and San Diego, there's lots of industry that hires our graduates. And then, of course, up in Northern California, maybe 6 hours away by car. We have a lot of graduates working in Silicon Valley and working in industry. So it is a nice place to be for industry. And then in terms of academia, if you go on to academia and do a PhD, there's USC here in LA. We have, 2 other big universities. We have some big universities up north. And so it is, I think, an exciting area to be in. Exciting part of the country to be in. And it's nice to be in California. We have a question in the chat. Okay, so the question is, what if you have a lower GPA initially and then your GPA came up? as you went along in undergrad. You know, an increasing trend is always good. So particularly if, each application is read by the admissions office and it's read individually. And, I know there's some cases, particularly if in your first couple years of undergrad, your scores weren't as high, but as you got into your technical subjects that you really enjoyed, the scores came up. That's always seen favorably. If you had some if some of those low scores were on things unrelated subjects, like let's say you had a low score in history or, we look at the technical scores more carefully. And then any kind of improvement trend is always helpful. So if it looks like there's some upward trend, it's good. Funding opportunities from Applied Physics Department. So the master's program is not funded. And so as an MS student, the MS program is tuition paying. However, there may be opportunities if you do transition if you qualify, if you do well, and you find a group you like, and you qualify to continue on in the PhD program, then the PhD programs are funded. In addition to that, I don't know if we have any domestic students here or not. Maybe not. If we do have any domestic students, there are external funding opportunities for domestic students. For international students, the funded opportunities really come in the PhD stage. If you get admission to a follow-on PhD program.
And then I wanted to add also, there are a few, they're quite competitive, but we do have some partial merit-based scholarships for master's students. So those are offered by the School of Engineering, but as Professor Povanelli said, most of our master's students are self-funded in some way or with an external scholarship, but we do offer just a few partial scholarships.
All right. Well, thanks to everyone for attending. And if you have questions afterwards, most of what I went over today is on our webpage. As you saw, it describes the program and the requirements. And Cami has put her email in the chat for questions about Fulbright. For those who are Fulbright, congratulations on that. And congratulations on the Fulbright grant to our participant who was asking about that. And so we hope that you will consider the program, and thanks for attending so we can tell you about it today.
Thank you so much.